So welcome back to the channel, or if you're new here, I'm Sunny and this is Someone Else's Cloud. So recently I saw a blog post that was posted on LinkedIn and it was titled Manage Azure IPAM with Terraform. And this kind of piqued my interest, so let's get straight into this. So the post was from a blog called Mateus.engineer. I'll share the link below so you can go through it in your own time. So before we get into this, let's quickly talk about the service that everything is operating on. So it's called Azure Virtual Network Manager. So basically it's a centralized managed service that enables you to group, configure, deploy, and manage virtual networks globally across subscriptions and tenants. As organizations scale their cloud infrastructure, managing multiple virtual networks across different regions and subscriptions becomes increasingly complex. Azure Virtual Network Manager addresses this challenge by providing a unified pane of glass for network administration. So let's flick back over to the blog. So let's quickly cover what is an IPAM and what are the benefits of using one. So an IPAM is an IP address management system. And it's basically a centralized system that allows you to inventory and manage your network address spaces. Now, this doesn't need to be in Azure. It can be on-prem IP addresses. It could be other clouds. It could be anywhere. But let's specifically talk about Azure. So you can basically allocate network address spaces, understand where they're assigned, what VNets, what metadata you want to include. You can also integrate that into third-party systems, as well as things like firewall rules. You can basically have other systems pulling data off, which can generate, say, whitelists or blacklists, as well as capacity manage your network address space. So see an overall view of what your consumption is to ensure that you're not running out of address spaces. Now, the key challenges I've seen in the past is a long time ago, we did not have access to an IPAM system. So I basically created a whole bunch of network address spaces pre-carved out in a table in Confluence, which is terrible. You can imagine all the effort as well as all the manual tasks to keep this thing up to date, and most of the times it was not kept up to date. And then eventually we moved to Python scripts that ran in pipelines that would access a system called PHP IPAM, which I'll put the link below if you want to check it out. It's an open source IPAM product. That would mean that Python scripts would run in the pipeline, but they would not really sit in code or anything. So there'd just be this thing that just pulls address spaces and updates it. And then on top of that, there is a Terraform community provider for PHP IPAM and Terraform, but I never tested it. And I think a lot of people would be iffy on it because it was not really maintained or updated often. And the other challenge with PHP IPAM was you could not really segment permissions. So it'd just be like admin or reader, but you couldn't really allocate them to different VNets or address spaces and things like that. So that became a challenge. So this blog specifically talks about using the pool feature in the Azure Network Manager. So what we're going to do is we're going to codify this. All the code's pretty much all here. And I will basically show you how to deploy it. And yeah, Mateus here has done a lot of the work. So let's just go straight into VS Code. Okay, so let's just create a new file. And we'll just call it main.tf. Being the purposes of a demo, I will basically just put everything in one file page. Now, the feature in itself, which is the Azure RM Network Manager IPAM tool, was released in version 4.23.0 of the Azure RM provider, which was released on the 14th of March, I believe, this year. And the blog does say that data sources did not exist, but they do now. And that came out in version 4.37.0, which is the basically the same sort of resource type, but it's a data source. And that basically means if you created your pools in, say, the hub code or platform code, you could use a data source on this side to look up those names and then pull out the IDs and then create your VNets and so forth. So let's go back to this page. So we've done this part. So what we want to do though is we want to flick over to this. So we will get the latest of 4.0. We need to add a subscription here. So let me quickly find my subscription. Okay, so I've just added my subscription here. Let's just format that. And then what we're going to do is go back to the blog. and we'll copy the locals. So the locals just defines the region. So I'm going to go Australia East and just defines a CIDR. So if we go through here, we will copy this. So this will basically create a Azure RM Network Manager, and it will create it at the, or add the name of Network Manager and then the location above. And it will go to a default resource group, which I'll need to create. And then there's a scope, which is bound to the current subscription. So you can add subscription IDs or management group. But let me quickly create a resource group, which is this. And we'll just call it default as well. Ooh. And we'll give it a name, which will be, just say IPAM demo. Let's just call it that. Then location will just be local.location. Okay, so let's just format that. By the way, if you haven't seen my videos, I have a lot of little aliases. So here, this is where we actually create the main IPAM. So this will create the IPAM pool in itself, and it will just use the same sort of values. But what this will do is create it inside this Azure Network Manager, and it will use the other CIDRs. So let's go back to the blog, copy all this. So this will create 4 pools, but let's cut out 2. Don't need that many, so we'll just create East and West. So let me just remove this. So previously I've had weird errors where it would error out saying there was a predefined value that didn't exist. So then I just reapplied and it worked. So I think the provider is a little buggy, but let's go ahead and create this. So what I wanted to show you is I have another tool which is called Terraform-Repl, but I just have a shortcut which is TFR. So what this allows you to do is initiate a console session like Terraform console, but it allows you to dynamically update configuration files on the fly and then see values. So previously, if you look at this, so if I go local.CIDR, that will show local.CIDR. It won't because I haven't done an init yet. Let me quickly do an init. So to make sure we have the latest provider, which is 4.45, and let me run it again. So if we go local.CIDR, this will show the CIDR. Now, previously, if you use Terraform console in itself and you try and change these values, you'd have to kill the session and start the console again. But with Terraform-Repl, it runs it dynamically. So you can see here, I can update a config and it will automatically update itself. Which is very handy when you're writing complicated loops and you need to understand what attributes you need to get or read certain keys. So it's very handy. I might do another video on it, but it's called Terraform-Repl, which is Terraform-Repl is the name. Maybe I'll do a video on it quickly. Let's go back to this. So what I wanted to show you though, what these values are doing. So if you look at this CIDR subnet, obviously it's splitting up that CIDR and then it's basically choosing certain values. So you can see there. And then if we just change this will get the first, I think, subnet. I don't really use it often, but I imagine that's what it's doing. So you can see there. So I just wanted to show you that. So now if I just do a Terraform apply, this should pretty much create the RG, the Azure Network Manager, the IPAM pool, and then the 2 pools inside it. So we'll just let this quickly run. So if you have a quick look here, it will create the Azure Network Manager, the pools, the main pool, that was the east above, and this is the west. And then it'll create the resource group as well. So if we quickly just flick over to the Azure portal and we just have a look at resource groups, you can see here we've got IPAM demo, and you can see here. So we got the network manager and we have the IP pool, and then we should have the pools below it. So you can see there, east and west exist, and that's pretty much done. So if we quickly go through the actual pool, so this is the main pool where we have sub-child pools under it. So if you look at allocations, you can see here where we have 2 child pools, and they're the 2. So these are the names that you need to reference when you're creating certain things. So as I mentioned, there was no data lookup before. So let's go and find the data lookups. Where's the data lookups? Okay. So we'll do that, and then we'll flick back, and let me quickly grab the IPAM pool. Okay, so although this code all lives together, I could reference values like this and just call it default.name, but I just want to show you that we can do a data source call from somewhere else. So instead of that, I will just be putting static values. Now, if you had a global config, you could pass these names through that way. But what we'll do is we'll just call this default. We'll call it demo. So these would be the demo names. Now what we need is the network manager name. Now, if we go to network manager, we will just copy this. So, and then the resource group name will just be what I have here. Or I should have just made these local references. So that should pick up the network manager demo. So then this will be network manager, and this will be demo.id, and this should be data. And then this will be just the name. So we will put it in east. So this will be the name. So these are the attributes required for a data lookup. So you can see here, we need the name of the network manager as well as the resource group it lives in. And then we also need, for the pool, we need the actual name of the pool and then the ID of this network manager. Let me tidy this up a bit. Let's do a Terraform validate. Let's make sure that I have the correct values. Now what we'll do is we'll go back to the blog. So you can see here there's outputs that that Mateus is showing because the challenge was the data lookup didn't exist. I can't remember where he mentions that, but he mentions it somewhere in here. He also shows a really good example of how you would create a virtual network. So you can see here, you'd basically create a virtual network. You put in the name, the resource group location, but this is where it changes. You have address space. Now, if you've ever deployed VNets in a large scale environment, you have the frustration of when you get the error that says it's a conflicting IP address and you cannot create this VNet. So, you know, ideally having your IP addresses inside the IPAM, inside Azure Network Manager would be great. But, you know, in the real world, there's still potentials of virtual networks being created outside of that. So, you know, it's not perfect, but ideally if you had everything managed in the IPAM, you would not have these conflict problems. So this is now what a VNet block looks like. So if I just go back to this, now we're just going to deploy in the same location, same resource group for now. Like I said, this is purely a demo. But what we're going to do is let's do some weird number like 35. So we're just going to call this VNet app 35 just so we can clearly distinguish what it is. This will go into the default resource group, which is current resource group, and we're just going to do 35. So what is really good about this is I generally don't know subnet CIDRs off the top of my head. I'm always using subnet calculators and everything. I really scratch my head on them sometimes. It's easier to just go ChatGPT and tell me. But what I love about this is you can just put in the number of hosts and then it will do Azure Network Manager will do all the thinking for you and create the CIDRs for you. So you just specify what addresses you want. So I'm just going to do some odd number like 35. And then we need the pool ID, which is from this data lookup above. So it'll be data dot this, and then it'll be demo dot ID. But just to show you from an example point of view again, I just want to show you I can do something like, let's just go, you know, some other random number like 125. So this will create another network with that number of hosts available, or the next closest anyway. So if we just go Terraform-Repl, and if we quickly go to Azure, if we have a look here under allocations, we will have nothing. So if we go back to this, you can see it's going to create 2 new virtual networks under the same RG, and you can see the number of IP hosts. So that means my Terraform code is working fine. And if we just go back to this, okay, so you can see here we've got 2 new VNets. So you can see if we flick to the 35, which is the 35, you can see here that it's basically created a new VNet with a /26 and 64 usable addresses. So obviously it's the next available that it carves out. And then the other one is 125. And you can see here I've got 128, which is a /25. So it's quite straightforward. And you can also see here where it shows you the available address spaces, and it just gives you everything available. Okay, so that's pretty much it. So I will share this link below for this blog. Definitely recommend that you have a look at it, and it could be a new way that you manage your network address spaces, because I would definitely move to something like this because I prefer everything to be in code and be stored in a repo, so it becomes the source of truth. But let me know what your thoughts are and what the challenges you have, and I'll catch you in the next one. See ya!